And the last oral presentations of the day is the origin determinations of Paraiba Tourmaline using LA-ICP-MS, the methods of quantitative analysis and its applications to samples with low CU contents by Kentaro Emori. Hello.
Hello.
Can you hear me?
Yes.
Perfect. Okay,
Yes.
great. It's now time for you.
Can I start?
Okay, it's perfect.
Okay.
Okay.
Okay. I'm Kentaro Emori from Central Gem Laboratory in Japan. First of all, I would like to appreciate opportunity to give this presentation. Today, I'm going to talk about the origin determination of Paraiba Tourmaline using LA-ICP-MS, the method of quantitative analysis, and its application to samples with low copper content. Paraiba tourmaline is a part of tourmaline that shows blue to green color. The main color is caused by copper. It was originally discovered in Paraiba State, Brazil, so it became known as Paraiba tourmaline. Following the discovery, copper-bearing tourmaline was found and produced from Nigeria and Mozambique on the African continent far from Brazil. The African tourmaline are also called Paraiba tourmaline regardless the origin in these days. However, there is a demand for origin determination in the gem market, and many studies have been published on the possibility of origin determination. In this talk, we present a method for quantitative analysis of tourmaline by LA-ICP-MS and show an example analysis of Paraiba tourmaline with a low copper content. The copper content is a key for origin determination. In Brazil, Paraiba tourmaline was first discovered in Batalha, Paraiba State. But since the 1990s, it has also been produced in Rio Grande do Norte, which adjacent to Paraiba State. There were Quintos and Murung mine in Rio Grande do Norte, but Quintos mine has been closed more than 10 years ago. Paraiba tourmaline is still popular in Japan, and the stone mined before the closing and supplied to Japan after cut and polished. Some stones from the Quintos mine are of low quality, i.e. very light color and have low copper content. The light color tourmaline is produced in Mozambique as well. We are required to distinguish origin of light color tourmaline, Quintos or Mozambique. In this presentation, we focus on the product from Quintos and Mozambique. Here are the samples used in this study. For Brazilian samples, we collected samples from the Batalha mine, Quintos mine, and Murung mine. And as for African tourmaline, I used samples certified to be from Mozambique and Nigeria. These were divided into 3 groups: blue, green-blue to blue-green, and green. And LA-ICP mass analysis were performed. At first, we introduced the quantitative method. Tourmaline has a complex chemical composition as described here. There are 2 problems measuring with LA-ICP mass. One is the problem of international standard elements, and the other is the lack of suitable standard samples for measurement of lithium and boron. These standards are not suitable. First, as step 1, we perform tentative quantitative analysis other than lithium and boron. It is not a measurement of exact concentration, but the quantitative analysis is performed to calculate the mole ratio of the contained elements. In step 2, we calculate the mole ratio of the cations based on the result obtained step 1 and adjust the charge balance calculate so that anion is minus 58. Composition formula is calculated from the mole ratio of each cation. At this time, some assumptions are introduced as shown on the left. Details is explained in the next slide. In step 3, we find the weight concentration of each element calculating back from the composition formula. The calculation method of this composition formula is shown here. Calculate the molar ratio with silicon as 1 from the measured concentration. For all elements, A star is defined the formula given here. The number of atoms for each composition formula, APFU, can be calculated by multiplying A star by silicon APFU. E is defined as all cations except boron and lithium, and Y is defined as all elements except aluminum and lithium that enter the Y side. The following quotation is derived from the stoichiometric relationship. Silicon APFU can be calculated from this formula, and the number of atoms per composition formula of each atom can be calculated from the definition. This method can also be applied to EDX and EPMA, which are not useful for quantitative analysis of lithium and boron. Here shows an example of actual element measurement result. At first, analyze with LA-ICP-MS. After that, calculate the number of atoms per formula unit using the method introduced previous slide. Finally, calculate the concentration from this unit formula. Now, I talk about origin determination. Here is the elemental plot of samples analyzed this study. This slide shows plot on the blue Paraiba Tourmaline. A plot of copper and gallium is shown in the lower left. Some samples from Quintos overlap with those from the Mozambique in this region. The top right plot shows that tin is detected in Mozambique, while Quintos is almost below detection limit. You can see that Quintos and Mozambique are separated in this plot of gallium/germanium versus zinc. This slide shows plot on the green-blue to blue-green tourmaline. Looking at the lower left plot, we can see that both Mozambique and Quintos sample have a very low copper content. As shown in the upper right, zinc content from Quintos scatters, while from Mozambique are low, in a low region. Clear reparation is found when zinc versus gallium versus germanium are plotted as shown in the lower right. Finally, plot of green color Paraiba Tourmaline are shown. Green Paraiba Tourmaline from Mozambique are very rare and measured data are limited. As shown in the lower left, Samples from quintos is characterized by lower gallium content as well as copper. Also, as shown in the upper right, the amount of zinc is large, and this plot in the lower bottom shows iron concentration scatter. I will summarize the contents of my presentation. Paraiba Tourmaline from the Quintos mine in Brazil has a very low copper content, and there is concern that it can easily be mistaken to be from Mozambique products. Analysis of Paraiba Tourmaline using LA-ICP-MS is very difficult due to its complex composition, but quantitative result can be calculated by incorporating some assumptions. This method can also be applied to other analytical instruments such as EDX and EPMA. Samples Quintos mine and Mozambique can be separated by elemental plotting even if they have the same color as well as other origins. Thank you for your attention. Thank you.
Thank you so much. Thank you very much. All right, ladies and gentlemen, don't forget that we also have tomorrow as well for the GIT 2021. And here are the parts of the GIT 2021, the 7th International James and Jury Conference. And we will meet once again tomorrow from 9 a.m. onwards. And I would like to extend a big thanks to all of the participants, both at Manijan Resort, Chantaburi, and those who are watching through the live streaming. And today at 6 p.m., we will have the welcome reception next to the swimming pool. You all can join. And don't forget to complete the evaluation form. And the e-summary will be available on 10th of February 2022 at www.gitconference2021.com. See you again from 9 a.m. onwards tomorrow. Thank you so much. สวัสดีค่ะ